Alright, let's look at the homework 14.3, problem number 10. Alright, so we have an ellipsoid and we intersect with the plane y equals 1. Alright, so let's try to see what it looks like. Alright, so I'm going to open up GeoGebra and then I'm going to go to View, and then I'm going to open up a 3D graphics. And I can probably close the graphics, regular graphics. Oh, sorry, I actually turn off. Alright, so here. Alright, so let's sketch the ellipse here. So you have a 3x squared plus 2y squared plus z squared is equal to 51. Alright, so we have this ellipse right here. Alright, I'm going to just step back a bit. Alright, then we have a y equals 1, so it's going to be a plane, y equals 1. So that's going to be a plane. Alright, then what we want to do is we want to find a tangent line at, let's see, 4, 1, 1. Alright, so I'm going to just place a point, 4, 1, 1. Alright, so we have that. So we want to find, a tangent line there. Alright, so let's try that. Alright, so let's see. So we are plugging in y equals 1. So I'm going to plug in y equals 1. So the equation becomes 3x squared plus y equals 1. So it's going to be just 2 plus z squared is equal to 51, right? Then I'm going to just go ahead and subtract 2 so it looks a little bit better. So you have a 3x squared plus z squared, and then is equal to 49. Alright. Then we just we want to know the slope of it. So let's try to find, let's see, dz, derivative of z with respect to x. Right? So let's take the partial derivative with respect to x. Right? So let's derivative of that is going to be 6x, and the derivative of this is going to be so 2z. Then we have to take the partial derivative of z with respect to x. Alright, so this is equal to, derivative of 49 is going to be 0. So we got that. Alright, then let's find the solve for dz, the partial of z with respect to x. Alright, first step would be I'm going to subtract 6x from both sides. So we get the 2z partial of z with respect to x is equal to negative 6x. Alright, then we can just divide through by 2z. So we have a partial of z with respect to x is equal to, it's going to be negative. 6 divided by 2 is 3, and then you have a x and over z. Alright, so since x value is 4 and z value is 1 at that point, so if you plug it in, so you have a negative 3 times 4, and then you have a z is 1, so plug in 1. So this is going to be negative 12. Alright, so the slope is going to be negative 12. So we're looking at this. So the slope is actually going down like this, right? So when the slope is going down like this, and if you look at the run and the rise is going to be, alright, so we're going to have to go, so let's say run is 1. Right, so that's in the x direction, and the z direction is going to be negative 2. Sorry, negative 12, I should say. Right, so the direction vector, you can think of it as, so direction vector, say v, of that tangent line would be, All right, so x component is 1, and there's no y component because this is the intersection with y equals 1. So there's no y component. And then z is negative 12. All right. So if you want the line, we can just say, all right, so we have x comma y comma z. All right, this can be found by simply take this point, which is 4 comma 1 comma 1. Then you can add the multiple of this vector. So it's a 1 comma 0 comma negative 12. All right. I guess I can probably look at it as a vector, so maybe I should use a vector notation here. All right, so I'll just write it as a vector here and the vector there. All right, so this is going to give us, all right, x comma y comma z is going to be equal to, all right, so you have a 4 plus t and a 1 plus 0, 1 minus 12t, right? So that would be the equation. So let's try to see if that looks right on GeoGebra, right? So I'm going to just write the, it's going to be 4 plus t, comma 1, comma 1 minus 12t, right? So hit enter. All right, so you can see that the equation we got is going to give us the tangent line at this given point, 4 comma 1 comma 1. All right, so let's type it in, and let's see, I actually messed up here. So I'm going to say x is going to be equal to 4 plus t, and y equals 1. And then z is going to be equal to 1 minus 12t. All right, let's check the answer. Submit for testing. All right, it came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.